welcome to the third and final topic of Chapter 5, STP concept. In this video, we will be discussing 5.3 evolution of STP. There are different implementations or versions of STP, though many professionals refer to it generically as spanning tree or simply STP. However, it is very important to refer to its implementation or standard in order to communicate its concept correctly. Like you have to be more specific on which implementation of spanning tree you are talking about, such as rapid spanning tree protocol or RSTP and multiple spanning tree protocol or MSTP. In the latest IEEE document on spanning tree, which is the IEEE 802.1d-2004, it says that, I quote, STP has now been superseded by Rapid Spanning Tree Protocol, RSTP, unquote. The term STP is used by IEEE to refer to the original implementation of spanning tree, and RSTP to describe the version in the IEEE 802.1d-2004 standard. The primary focus will be on the current standard and Cisco proprietary implementations of RSTP and STP because they share a very similar terminology as well as methods for implementing loop-free path. Cisco switches with iOS version 15 or later run PVST Plus by default. This version incorporates many specifications of the IEEE 802.1d-2004 standard, but remember, switches must be explicitly configured for rapid spanning tree mode in order to run RSTP. The table below describes the different versions or implementations of STP. STP is the original IEEE 802.1d. It is also referred to as Common Spanning Tree or CST. It implements a single spanning tree instance for the entire bridge network regardless of the numbers of VLANs. PVST Plus or per VLAN spanning tree is a Cisco enhancement of STP that provides multiple instances for each VLAN in the network. It supports Portfast, uplink fast, backbone fast, VPDU guard, VPDU filter, root guard, and loop guard. 802.1d-2004 is an updated version of the STP standard incorporating the IEEE 802.1w standard. RSTP or Rapid Spanning Tree Protocol or IEEE 802.1w is an evolution of STP that provides faster convergence than the original STP. Rapid PVST Plus is a Cisco enhancement of RSTP that uses PVST Plus and provides a separate instance of 802.1w per VLAN. Each separate instance supports Portfast, VPDU guard, VPDU filter, root guard, and loop guard. MSTP or Multiple Spanning Tree Protocol is an IEEE standard inspired by the earlier Cisco proprietary Multiple Instance STP or MISTP implementation. MSTP maps multiple VLANs into the same spanning tree instance. And of course, MST or Multiple Spanning Tree is the Cisco implementation of MSTP, which provides up to 16 instances of RSTP and combines many VLANs with the same physical and logical topology in a common RSTP instance. Each instance supports Portfast, BPDU guard, BPDU filter, root guard, and loop guard. Now, let us discuss a little bit of RSTP concepts. RSTP, defined in the IEEE 802.1W standard, supersedes the original 802.1D standard while retaining backward compatibility. When we say backward compatibility, this means that new system is compatible or still works with a legacy or older systems. RSTP terminology remains primarily the same as the original one, and most parameters or user-defined configuration settings have been left unchanged. So, users or administrators familiar with the original STP standard can easily configure RSTP. STP and RSTP uses the same spanning tree algorithm to determine port roles and topology. RSTP is faster in terms of recalculations of spanning tree when there is a change in the layer 2 topology, which means that it can achieve a much faster convergence for a properly configured network for as little as a few hundred milliseconds. That is fast, right? Also, if a port is configured to be an alternate port, it can immediately change to a forwarding state without waiting for the network to converge. Take note that Rapid PVST Plus is the Cisco implementation of RSTP on a per VLAN basis. With Rapid PVST Plus, an independent instance of RSTP runs on each VLAN. RSTP port states and port roles. Looking at the diagram on the left, RSTP has only 3 port states as compared to the original STP, which has 5. The disabled, blocking, and listening states are merged into a unique 802.1W discarding state. Learning and forwarding state remains the same. The diagram on the right shows the root port and designated ports are the same for both STP and RSTP. However, notice that there are 2 RSTP port roles that corresponds to the blocking state of STP. Remember, in STP, if a port is not a root port or a designated port, then it is a block port. RSTP has 2 port roles for this purpose. Now we would ask, what is the difference between an alternate port and a backup port in RSTP? Well, if you look at the example topology, an alternate port has an alternate path to the root bridge, as shown in one of the ports on S2. Now, a backup port is a backup path to a shared medium such as a hub, the one connected to S3. But since hubs are considered legacy or old devices, backup ports are less common in a switch networks nowadays. Portfast and VPDU guard. As we have learned earlier, when a switch powers up or when an end device is connected to a switch port, the port goes through both listening and learning states. Each state waits for the forward delay time to expire. This delay is 15 seconds for each state, which amounts to a 30 seconds total delay. This delay can cause problems for DHCP clients trying to discover a DHCP server because the DHCP process may expire, resulting in the IP version 4 client unable to receive a valid IP version 4 address and therefore cannot access the network. But when a switch port is configured with Portfast, that port transitions or changes from blocking to forwarding state immediately, avoiding the 30-second delay, allowing end devices to access the network immediately. However, you have to make sure that Portfast is configured on access ports only. Access ports are ports where end devices such as computers or printers are connected. Why access ports only? Well, if you enable Portfast on a port that is connected to another switch, it would create a spanning tree loop, which is what STP is designed to prevent. When a switch is connected to another switch, VPDU frames are exchanged between them. Since Portfast is configured on access ports, those ports should never receive a VPDU frame. Once it does, then it can potentially cause a spanning tree loop. Cisco switches has a feature called VPDU guard. When enabled, it immediately puts the switch port in an error disabled state when a VPDU frame is received, thereby shutting down the port to protect against potential loops. The switch port must be manually configured by the administrator for it to work again. Alternatives to STP. Over the years, we saw the improvements of local area networks or LANs from a few interconnected switches to a router to sophisticated hierarchical network designs with access, distribution, and core layer switches. Organizations also required networks with greater resiliency and availability. Depending on how the network design is implemented, Layer 2 may include not only access layer, but also the distribution or even the core layers. These designs may involve hundreds of switches with hundreds of VLANs or maybe thousands of them. So STP has adapted to added redundancy and complexity with enhancement as part of RSTP and MSTP. Compared to routing protocols at layer 3, spanning tree does not offer the same efficiencies and predictabilities because one of the most important aspects in network design is fast and predictable convergence when there is a failure or a change in the network topology. Layer 3 routing allows redundant path and loops in the topology. If you remember from our previous discussion about TTL or time to lib for IP version 4 and hop limit field in IP version 6 that is decremented by the router. When these fields reach 0, the router will drop the packet. For this reason, some network environments are transitioning to layer 3 everywhere except where devices connect to the access layer switch. In other words, instead of the usual layer 2 connections, newer network designs use layer 3 connections between the access layer switches and distribution switches. This is possible with the use of multi-layer switches. Okay, so don't forget to do the module practice and quiz in your NetAcad account. This will help you evaluate your understanding of the chapter. So, in summary, we have learned about the purpose of STP, which is to prevent both physical and logical layer 2 loops when redundancy or redundant path are implemented on the network. Without STP, layer 2 loops can form, causing broadcast, multicast, and unknown unicast frames to loop endlessly, bringing the network down. STP is based on the algorithm invented by Radia Perlman. Her spanning tree algorithm, or STA, creates a loop-free topology by selecting a single root bridge. And based on that root bridge, all other switches determine a single least cost path. We also have learned about STP operations, in which STA builds a loop-free topology in a four-step process. 1. Elect the root bridge. 2. Elect root ports. 3. Elect designated ports. And 4. Elect alternate or block ports. BPDUs, or Bridge Protocol Data Units, are used by switches to exchange information about themselves and their connections. BPDU contains the bridge ID. The bridge ID is composed of the priority value, extended ID system, and the MAC address of the switch. The switch with the lowest bridge ID will become the root bridge. From that root bridge, path information, or internal root path cost, is determined by the sum of all individual port costs along the path from the switch to the root bridge. Root ports are ports closest to the root bridge in terms of overall path. Then the STA will select designated ports. A designated port is a port between switches that has the internal root path cost to the root bridge. Then alternate port is a port that is not a root port or a designated port. Alternate ports do not forward data frames because they are in discarding or blocking state to prevent loops. In case of multiple equal cost path to the root bridge, the switch will determine a port using the following criteria: lowest sender bridge ID, lowest sender port priority, and lowest sender port ID. STP uses three timers: hello timer, forward delay timer, and max age timer. Port states are blocking, listening, learning, forwarding, and disabled. Also, in PVST, multiple instances of spanning tree is supported, allowing different root bridges for each and every VLAN configured on the network. For evolution of STP, here we have learned about different STP implementations and enhancement, such as the original STP IEEE 802.1b-1998, the updated version of STP, which is 802.1d 2004, RSTP, PVST+, Rapid PVST+, MSTP, and MST. Each has its own but similar implementation or enhancements of STP. Don't forget about how layer 3 allows for redundant path and loops in the topology. That is why, as an alternative to STP, some environments are transitioning to layer 3 everywhere except where end devices connect to the access layer switch. This ends our discussion of Chapter 5, STP Concepts. Please read the full curriculum in your NetAcad account for more detailed information.